Hey YouTube community, once again I'm Erisa to take you through online math lectures. In the most recent discussion, that was yesterday, we talked about the expectation of a discrete random variable. We said that for a discrete random variable, the expectation which we noted by E of x, okay, is given by E of x is equal to the summation for all x values, x times the probability of, okay, you multiply x by the probabilities and sum the products for all the x values of the distribution. Okay, so before we move on to discuss what I want us to talk about today, I want to give you an example about this and then we move on. So we have this example. They have given us information in a table form. Okay, so and they are saying the table shows the probability distribution for a random variable x. The question is calculate A, the value of C, B, the expectation. So this is really something very simple. Every time they talk about the value of a constant, in most cases it is all about summing probabilities and equating to one. But if there is more than one constant, then you might need something else. Okay, so here this is just a single constant C. Let's sum probabilities equate to 1 and then get the value of C. Okay, after we shall be able to get the expectation. How do we find C? We know the summation for all x's involved, probability of x is equal to, okay, this must give you 1. So let's look at the probabilities. I have C plus C squared plus C squared plus C n plus 3C squared plus 2C must give us 1. Okay, so this is going to be a quadratic in C, okay, because we have C squared, we have C, and we have a constant, which is 1 in this case. So let's have the C squared. I think we have 5C squared plus how many C's? 4C minus 1 equals to 0. That is if we arrange a quadratic in a C. So we have to look for two factors that sums to 4 and the product is negative 5. When I look at these factors, it's going to be 5 and the negative 1. So this is 5C squared plus 5C minus C minus 1 equals to 0. Okay, this is a 5C into, okay, C plus 1 minus C plus 1 equals to 0. So 5C minus 1, if you factor out that bracket C plus 1, it leads you to this step C plus 1 equals to 0. So if you have a product of two factors and it is 0, either of the factors is 0, but you can't tell. So we can start either 5C minus 1 equal to 0, implying that C is equal to 1 out of 5, or C plus 1 equal to 0, and this will mean that C is negative 1. Okay, but there is something we know about probability. The probability of, okay, the probability of an event cannot be more than 1 or cannot be negative. So this means that the value of C we agree on, C is equal to 1 over 5. Why are we discarding C equals to negative 1? The reason is C is a probability. When you check our table, 0 has probability C, 1 has probability C squared. So probability will never be negative. It is always a number between 0 and 1. Okay, so in this case we discard negative 1 because probability cannot be negative 1. Okay, so we have got the value of C, it is 1 out of 5. Now the next part, we get the expectation of x. How do we find it? We sum for all x's involved x times the probabilities. Okay, now what are the x values involved? We have 0, okay, so that will multiply with c, and plus 1 will multiply with c squared, plus 2 will multiply with c squared plus c, then plus 3 will multiply with 3c squared plus 2c. Okay, so let's multiply. This is c squared, okay, we have c squared plus 2c squared plus 2c plus 9c squared plus, and that's gonna be 6c. Okay, so what do we get? You collect like terms. 10, that's 12c squared, plus the c's 2 and 6, 8c. Okay, so we know the value of c. It's just a matter of substituting in. The value of c is 1 out of 5. So if you substitute 1 out of 5, you'll have 12 times 1 out of 25 plus 8 times 1 out of 5. Okay, so what's the expectation? Okay, so this 25 divided by 5, that is a 5 times 8 is 40. So this is 52 out of 25. And this will be 2 point something. Okay, 2.04. That's what I'm trying to reach. 04, 25, that's 100. I think 2.08. Okay, you know, I'm just using my head, but I think it is true that the expectation is 2.08. Remember, the expectation is an x value that must lie within the given x values. In this case, we have 0 up to 3. So the expectation is within that range 0 to 3. It is a value within 0 to 3. It cannot be more than 3 and it can't be less than 0. So expectation is an x value, a small x value. All right, let me hope that's so clear. So this is it. If I have not calculated so well, you check with your calculator, but I think that's 2.08 because 25 goes into 50 twice and the balance is 2. If you add the 2, it will be 20. 20 cannot be divided by 25, so you add another 2. So it is, I think, 2.08. All right, that is it. Dear class, I was like, I should first remind you what we covered in almost the previous lesson. That was expectation. But what we want to look at today is the expectation of any function of x. So let's look at the expectation of any function of x, e of g of x. So that's what we want to discuss, okay? So how do we find the expectation of any function of x? We are going to use the definition of expectation we have looked at. Let's write some information. The definition of expectation can be extended to any function of x, okay, such as 10x, x squared, 1 over x, okay, x minus 4, okay, and many other functions. So if we can extend the definition of expectation to any function of x, then let's generalize. In general, if g of x is any function of the discrete random variable x, then we know that the expectation of that function, which is g of x, is the summation for all x's involved. Okay, you get g of x and multiply by the probabilities. That is it. It is like the way we have been calculating expectation. Okay, so we can just give examples of functions and just fill in the formula. For example, okay, e of 10x equals to the summation of 10x times the probability of capital X is equal to small x. Then e of x squared is equal to the summation of x squared times the probability of capital X is equal to small x. Okay, you can also see that e of 1 over x equals to the summation of 1 over x, okay, times the probability of capital X is equal to small x, and the e of maybe x minus 4, any function of your choice, okay, is equal to summation of x minus 4 into p of capital X is equal to small x. So that is it. You just get the function and multiply by the probabilities. That will be the definition of any function of x. Okay, let's look at an example and see how we apply this. So this is the example. They have given us a table having information. The values of x are 1, 2, 3, and the probability is 0.1, 0.6, and 0.3. So the first part is what we have been dealing with. Calculate e of x. E of x equals to the summation for all x's, x times the probability. Okay, so this is equal to 1 times 0.1 plus 2 times 0.6 plus 3 times 0.3. So we have, let's see what we get here. 1, that's 0.1 plus 1.2, that is 1.3, 1.3 plus 1.9, okay, is 2.2. So the expectation is 2.2. So part A is answered. What about part B? Okay, the expectation of 3. Okay, what do we do? To get the expectation of 3, we know that this is going to be, we sum for all x's 3 times the probabilities equals small x. That's the definition. Okay, where there is x, now there is 3. So we get 3 and multiply by 0.1 plus 3 times 0.6 plus 3 times 0.3. Okay, just the same thing as 3 into 0.1 plus 0.6 plus 0.3. But we know that these probabilities sum up to 1 since it is a discrete random variable. Therefore, the answer is 3. Okay, so there is something interesting about a constant. Okay, I can write it here for you if you want. The expectation of a constant is a constant itself, is a constant itself. Okay, the expectation of a 3 is a 3, the expectation of a 4 is a 4, the expectation of 9 is 9, the expectation of 20 is 20. So it will be that constant itself. That will be the expectation of a constant. So part C, they want us to find the expectation of 5x, e of 5x. By definition, this is gonna be the summation of 5x times the probability of capital X is equal to, okay? Multiply the values of X by 5, and then after you multiply by their corresponding probabilities. So this is going to be X is equal to 1, we have 5, times the probability, which is 0.1, okay? Plus X is equal to 2, that will be 10, times the probability, which is 0.6. Then X is equal to 3, we shall have 15 times 0.3. Okay, what do we get? 0.5 plus 6 plus, that's 15 by 3 is 4.5. Okay, so if you add, that's going to be 11. So this is 11. Okay, now there is something also interesting about this. Okay, let me note it for you. Note the expectation of 5x is also the same as 5 times the expectation of x. This is 5 times 2.2, which is exactly equal to 11. So we would have, left out the other part of calculation if we knew something about this. But it is knowledge where we are still building. That's what we call learning. You start from what you know, and then proceed what you don't know, and then start doing what you don't know. Okay, so that is it. That is mathematics. Now, the last part here, that's part D. D talks about finding the expectation. Indeed, they want to get the expectation of 5x plus 3. Okay, so this is going to be the summation. The function we're having here is 5x plus 3. So it is going to be the summation of 5x plus 3 times the probability, which is x is equal to. So get the values of x multiplied by 5, add the 3, and multiply by the corresponding probabilities after sum for all of those x's. Let me just write here all of x's. So what is it? When x is equal to 1, that's 5, so we shall have 8 into 0.1 plus x is equal to 2, that will be 13 into 0.6, and the x is equal to 3, that will be 5x, which is 15, plus 3 is 18 times 0.3. Okay, so this is 0.8 plus, okay, 18, that is 60, 78, 7.8 plus 18 by 3, 24. Okay, that's 344.4. So when you add, you end up with the 0.8 plus 7.8 plus that is 8.6, 12.6, 13. That's what I'm getting. It is shocking. I'm getting 13, but I don't think whether 13 is correct because it's 14. Okay, so this is 14, not 13. 14, because 8, that will be 8.6. Okay, that's 9, 10. So it is 18, but here I think I made a mistake. Let me try to correct this. 1.8 times 3 is 5.4. So it gives us the answer as 14. Now, we can also try to note something here. So note that e of 5x plus 3 will be the same thing as e of 5x plus e of 3. But we have discovered that e of 5x is 5 times e of x plus e of 3 is a 3. So we have also discovered the e of 5x, okay, as 11. I think this is, from here we can say e of 5x is equal to 11. 11 plus 3 is the same thing as 14. So We can get it by just breaking it into this step here, and after we make use of the expectation, substitute, have the answer. Instead of going through all this lengthy calculation you are seeing here, we can just forego everything and we jump to this step directly here. Just feed in, end up with the answer. So without wasting time, that is it, ladies and gentlemen. So we have been able to define the expectation of any function of x. There are some important properties about this that you can write down. I will prove some for you, and then the rest you can go and try as a student. You are learning, so part of learning, practice is part of learning. If you don't practice, you'll never learn something. So keep practicing for better learning. So we can write that in general, for constants A and B, the expectation of A equals to A. Okay, the expectation of AX plus, or just AX, let's first begin with AX. The expectation of AX is equal to A times expectation of X, and then the expectation of AX plus B is gonna be A times expectation of X plus B. Okay, if you want and give me permission, I can go ahead and make some proofs for you, but of course nobody is going to ask you to prove this. Yeah, it's just that I just want to do it for you. The first one, A, they want the expectation of a constant A. Okay, we know we define this as the summation of A times a bit of capital X equal to small x. So what do we do in this summation for all values of x? Suppose we have values of x going up to x, from x1 up to xn. This is going to be A times the probability of x is equal to x1 plus A times probability of x is equal to x2 plus you add not until you reach the last one, which is x is equal to xn. Okay, I don't know that you understand by what I'm trying to write. If the x values, the variable is taking is x1, x2 up to xn, then multiply A by the probabilities of x is equal to x1. Okay, so this is the same thing as okay, A times the summation of all those probabilities, x is equal to x1 up to. Okay, so for all x's involved, and when you sum probabilities for a random variable, you end up with 1. So this is A times 1, which is equal to A, and therefore the expectation of a constant will always be a constant. Okay, so that's something which is really simple that you need to do. Then the second, I can prove for you also B, so you can see what I'm talking about. Okay, so this is gonna be part B. I have the expectation of AX. We are defining this as the summation for all x's, AX times the probability of is equal to small x. Now, this A is a constant, AX. Okay, A will move the different x values, but A is not going to change. So we can say that this is A times the summation of A of x into this is x into probability of capital X is equal to, this is a lowercase x, not a capital X. Now, x times probability is then summation that is equal to the expectation. So this is A times the expectation of x, and we are done. Okay. Lastly, we talk about AX plus B. C, we are talking about the expectation of AX plus B, and we want to prove that this is A times expectation of X plus a B. Okay, so what do we do? Okay, we know that this is the same thing as E of AX plus E of B. Okay, and the E of AX, we have proved that this is A times E of X plus a B, because E of B, since B is a constant, E of B is equal to B. Remember, there is something here which I may not prove for you right now, but it is a fact. If we have E of, these are functions of X, G of X plus H of X plus R of X, you have a sum of three different functions of X, and you want the expectation. It's the same as getting the expectation of G of X, and add it to the expectation of H of X, okay, and add this to the expectation of R of X, okay. That's exactly the same. That's why when I have E of AX plus a B, okay, I treat this as a function and this as a function, so I write this as E of AX plus E of B. But we have just proved that E of AX is A times E of X plus E of B, since B is a constant, E of B is equal to B. So that's something which is worth noting at this time as you go ahead to learn some mathematics. So ladies and gentlemen, I think I have proved these three important results, okay? So you can see that hence E of a constant will be a constant. If you have E of a constant times X, that's going to be a constant times the expectation of X. And if you have E of AX plus a B, you end up with A times E of X then plus a B. So these results are very important, ladies and gentlemen, as we move on with the discrete random variables and later on with the continuous random variables. So make note of this in your notebook. You shall always refer to that. Let us apply these three properties in solving this problem. So, example. Ladies and gentlemen, this is a question that we can easily solve. If you want, you can do the possibility space, but we can even do without the possibility space. So, X is the number of heads obtained when two coins are tossed. Okay, so let's look at the tossing of two coins. Okay, what the probability of getting tail? Okay, you don't have any head. The first is a tail and the second is a tail. So it is a fair coin, and this is going to be a half times a half, which is 1 over 4, because a coin has two faces. One is a head and one is a tail. If it is fair, it gives equal probabilities to any of the faces turning up. So if the first gives a head, the probability is a half, and the second gives a head, the probability is a half. So that's a half times a half, which is a quarter. Now, what about for one head? Okay, P of one head. This has two outcomes. It is either the first showing a head and the second showing a tail, or it is the first showing a tail and the second showing a head. So what is this? 1 over 2 times 1 over 2 plus 1 over 2 times 1 over 2 is equal to 1 over 2. Okay, you get a half. So what about the probability of getting two heads? Two heads. Okay, that means that the first shows a head and the second shows a head. Okay, the head. This is a half times a half, which is a quarter. So we have the probabilities. The question is, find the expected number of heads. What is the expected number of heads? So if we are to draw a possibility space, you know x, the number of heads, so we have x and probability of capital X equals to, we have either we don't have any head, or we have one head, or there are two maximum. So if that's the situation, then this is what we end up with. So 0, that's 1 over 4. This is a half, and this 1 over 4. And now the expectation, okay, of x, we just sum for all the x's, okay, probability of x times probability of, okay, equals 2. So what do we get? 0 times that is a 0. So we have a half plus a half, okay, a half plus a half, you end up with 1. So the expected value, or the expected number of heads, equals to 1. Next is the expectation of x squared. Okay, so here we have been given a function x squared. So what is the expectation of x squared? So part B and C are really very simple. When you look at the expectation of x squared, okay, so this is gonna be x squared times the probabilities, and the values of x we have are 0, 1, and 2. So when you square 0, that is a 0 times the probability, which is a quarter, then plus 1 squared is a 1 times the probability, which is a half, plus 2 squared is a 4 times the probability, which is a quarter. So 1 times a half is a half, then 4 times 1 over 4 is 1, and therefore it gives us the answer as 1 whole number and 1 over 2. Okay. Now this other part C, we follow the properties of expectation. These are two functions, x squared and x. So the same thing as expectation of x squared minus expectation of x. And we have the expectation of x squared is 1 whole number and 1 over 2, which is the same thing as the out of 2, minus e of x, which is a 1. It gives us a half as the answer. And we are done about that. So it's not really something hard. Now, in our next discussion, we are going to talk about variance of a discrete random variable. What is variance? How do we calculate variance? Is the mean or the expectation important in getting variance? So that's the next discussion, ladies and gentlemen.